distinguished guests, valued attendees, and ladies and gentlemen, very warm welcome to Global Spectrum Management Forum 2023. This event is hosted by the Central Radio Management Service, and my name is Min-Hwa Kim, and it's an absolute pleasure and honor for me to be your MC on this very meaningful occasion. Well, first of all, I'd like to convey my sincere gratitude to all of you for your presence today. Before we commence this forum, set your receiver to channel number 1 for Korean and channel number 2 for English. And thankfully, we are joined by many participants from various countries around the world, offline and also online as well. So let's take a moment to welcome online attendees. Hello. Give us a wave. Can you hear me well? Hello. So we have a representative from Cambodia. Where are you? Representative from Cambodia? Hello. Thank you for joining us. And we have also a representative from Thailand. Welcome. And we have also a participant from Malaysia. Please give us a wave. Welcome. Thank you for joining us. And we have also a representative from Romania. So I'm really happy that you join us. I hope you will stay with us until the end. Well, without further ado, let's begin the forum with opening remarks. So please join me in welcoming Mr. Jong-sang Kim, Director General of Central Radio Management Service. Please welcome him with a big round of applause.
Thank you. Ladies and gentlemen, distinguished guests, I am Jong-sang Kim, Director General of Central Radio Management Service, affiliated with the Ministry of Science and ICT. I'm truly delighted to join the third Global Spectrum Management Forum with all of you, government agencies, international organizations, research institutes, and corporate officials. Let me introduce the honored guests who celebrate this event. First, Dr. Jong-Soo Song, President of the Korea Radio Promotion Association, who will deliver the congratulatory remarks. And Mr. Mario Maniwicz, Director of ITU-BR, he will give a keynote speech. I would like to express my deep gratitude to radio management agencies from abroad, Mongolia, Cambodia, Vietnam, Rwanda, Thailand, Bangladesh, Indonesia, and Egypt. I also want to give my special thanks to Professor Il-Gyu Lee, Vice Chairman of ITUR SG1, and Dr. Jong-Han Hwang, Director of ETRI, who will lead the panel discussion. In addition, I would like to thank and welcome everyone who virtually participated in this forum through YouTube and Zoom. Our honored guest, CRMS was established in 1947, a specialized radio management agency in Korea. We have played a key role in managing radio waves utilized in national security and critical industries and services. In this process, CRMS has developed spectrum managing skills and technologies. To share these valuable experiences and know-hows accumulated over the 70 years, CRMS has signed MOUs with 14 countries. And we have been expanding cooperation in various ways, such as information sharing, expert education, advice program on spectrum management, and etc. Also, CRMS is actively participating in ITU or other international organizations and make every effort to share Korea's latest technologies complying with the ITR regulations. In the era of digital transformation, autonomous vehicle, drones, low Earth orbit satellite, and UAM services are emerging. As these new and complicated technologies are developed, an expected interference of radio waves have a critical impact on not only various industries, but also the safety of human life. The importance of radio management will become even greater in the era of 5G and 6G mobile communication, which will serve as the key infrastructure for enabling these new services. CRMS is advancing the radio management technology in order to manage the radio waves without any interference or jamming for the stability of new services. For this, we are researching ways of applying AI or big data technology to managing radio waves. AI technology can automate radio waves monitoring and managing. And AI technology is also expected to enable rapid and effective responses in case of harmful interference or disruptions. Our honored guests, we would like to share our new challenges and innovations and seek ways to develop technology together through the constructive dialogues. I hope that we could have a deep dive regarding these topics together and mutually cooperate through the Global Spectrum Management Forum as a platform. Have a good time and bring happy memories in Korea. Even after this forum, I deeply appreciate your attention. Thank you.
Thank you. He opened this forum with his warm message and inspiring words. Thank you very much. And also thank you for your hard work to make this event happen. Well, we proceed to the next congratulatory remarks. I'd like to invite Dr. Jung Soo-song, the president of Korea Radio Promotion Association. Dr. Song will now take the podium for the remarks. Please welcome him with a big round of applause.
Good afternoon. Nice to meet you. As introduced, my name is Jung Soo-song, president of Korea Radio Promotion Association, the organizer for today's event. I would like to begin by congratulating everyone involved and extend my gratitude to Jung Sam Kim, the Director General of Central Radio Monitoring Service, for hosting this event. I would like to thank everyone participating in this forum, both online and offline. Especially, I would like to express my warm welcome to those who have traveled from afar to attend this inspiring event. Thank you very much for honoring this forum with your presence. Representatives from Mongolia, I don't know where you are, Cambodia, Vietnam, Rwanda, Thailand, Bangladesh, Indonesia, and Egypt. Global Spectrum Management Forum is the one and only specialized forum on spectrum management issue. This year, we have reached our third year milestone, garnering attention from experts around the world. In our everyday lives, spectrum is widely used for various purposes. But it is also a limited resource, which means we have to manage it properly. In this regard, I believe today's forum is timely in that it addresses meaningful subject on spectrum management. As you see from the textbook, the forum book, the topics covered for today's forum will be from satellite communication to drones, to anti-drone, to UAM. Many experts are ready to deliver current issues and trends of cutting-edge satellite technologies and services. And experts from various fields such as next generation mobile communication and UAM are here today to give their insights. I am personally interested in low Earth orbit satellite and UAM, and I really look forward to those discussions. There will be also an opportunity for participants from major countries around the world to share their country's spectrum management policies. I hope through this sharing, we will lay the foundation for harmonized spectrum management. Outside the forum event halls, there is an exhibition on drones and anti-drone technology, all of which demonstrated their power in the ongoing Russian war on Ukraine. Generally, we would want to use spectrum in harmonious mode, but as you already have seen in the exhibition hall, it shows us the opposite idea of anti-drone, idea of shooting down the drone. It uses interference to disable drones, and indeed, interference of spectrum is another crucial aspect of our spectrum industry. Once again, congratulations on hosting this forum and best wishes on your future endeavors. Thank you all for participating, and congratulations and thanks to those involved in preparing today's event. Thank you. Thank you very much.
Well, thank you, Dr. Song, and he graced this forum with his one message. Through his remark, he highlighted the fact that this forum is now being held at an opportune time with a focus on what we really need to address and concentrate on, that is spectrum management. Thank you very much. And now it's my great pleasure to introduce today's keynote speaker, Mario Maniabic, the Director of Radio Communication Bureau, ITU. Mr. Mario Maniabic has prepared a recorded presentation video under the title of Spectrum Management and the forthcoming WRC 23. Let's meet him through the video.
Distinguished authorities and guests, dear participants, it is my pleasure to address you today at the beginning for this 2023 edition of the Global Spectrum Management Forum. I thank the organizers for having invited me, although I regret not to be able to be with you in person this time. Today, I will talk to you about spectrum management and the forthcoming World Radio Communication Conference 2023. As you know, the ITUR develops and adopts standards and best practices on the use of spectrum and satellite orbits. This is done through the work of ITUR study groups and the Radio Communications Assembly. On a higher level, we develop and update international regulations on the use of spectrum and satellite orbits. During a 4-year period, studies are conducted in the ITUR study groups, and the regulations are updated at the World Radio Communication Conferences, such as the forthcoming WRC 23. The Radio Communication Bureau also applies these regulations via frequency registration and coordination. This year, we celebrated the 3000th edition of the BR International Frequency Information Circular, which contains particulars of frequency allotments and assignments. Finally, the BR disseminates information on these standards and regulations in events like this one. International standards provide specifications and requirements for a specific application. They are developed collaboratively by the public and private sector, academia, and other regional and international organizations. The final approval of ITUR recommendations, however, lies in the hands of ITU member states. While these international standards are not mandatory, they are commonly implemented worldwide. Other very well-known standards are those related to the International Mobile Telecommunications Family, or IMT. We have approved standards for IMT 2000, or 3G, IMT Advanced, or 4G, and more recently for IMT 2020 or 5G, resulting in ITUR recommendations. We have now started the work on IMT towards 2030 and beyond, or 6G, by applying the well-proven IMT process. Following the timeline and the target at the beginning of this process, the ITUR developed a new report on future technology trends that was already published. At its June meeting, Working Party 5D has agreed upon the draft new recommendation, framework, and overall objectives of the future development of IMT for 2030 and beyond. This document has been submitted to the parent Study Group 5 that will meet now in September for adoption and subsequent approval by the membership. The IMT 2030 framework is the equivalent to the IMT vision in former IMT generations, and it can be considered as a basis for the standardization fora to develop the next generation of IMT standards. This new recommendation addresses the user scenarios for IMT 2030. As you can see in Figure 1, there are 6 user scenarios, 3 of which are extensions from IMT 2020 or 5G, which are the EMBB, the MTC, and the URLCC, and 3 are new scenarios, which are ubiquitous connectivity, integrated AI and communication, and integrating sensing and communication. It also encompasses 4 overarching aspects applicable to all user scenarios: sustainability, connecting the unconnected, ubiquitous intelligence, and security, privacy, and resilience. Finally, the recommendation lists the capabilities of IMT 2030. As you can see in Figure 2, 9 of these enhanced capabilities of 5G are 6 new capabilities for 6G technologies. The range of values that you see here are given for capabilities that are estimated targets for research and investigation of IMT 2030. Regarding spectrum management for satellite services, I highlight a few advancements of the work of the ITUR. Besides the work of international standards, I bring to your attention the recently approved handbook on small satellites that contains information on the applicable regulatory procedures for small satellites, including nanosatellites and picosatellites, and short-duration mission satellites. These were approved in the last Study Group 4 meeting in July. Study Group 4 also agreed upon 2 recommendations that will now follow the formal approval process. These recommendations refer to the protection of GSO networks against interference generated by non-GSO systems. Here you have all the references to the handbook and the 2 recommendations. Moving on to the forthcoming World Radio Communication Conference of 2023. After the 4-year study cycle, the WRC will take place from 20 November to 15 December in Dubai, in the United Arab Emirates. It will address the radio communication matters of worldwide and regional implications, and will consider the evolution of existing, emerging, and future application systems and technologies. You have here the link to the host country and to the ITU website, where you can find practical information and content-related matters, respectively. As you know, the main output of the WRC is the update of the radio regulations, the International Treaty on the Use of Spectrum and Satellite Orbits. For 117 years, this treaty has enabled radio communications to operate efficiently and effectively without harmful interference. Now, more than ever, with all the new terrestrial and space technologies and increasing demands for radio frequencies and satellite orbits, the radio regulations play an even more important role in assuring that countries or group of countries use these resources effectively and have equitable access to frequencies and orbits. Looking into WRC 23 agenda, it contains fixed, mobile, and broadcasting issues, aeronautical and maritime issues, science issues, and satellite issues. On the first quadrant are agenda items 1.1, 1.2, 1.3, 1.4, and 1.5 on fixed, mobile, and broadcasting services. These are some of the most debated topics, and the decisions of the conference will impact IMT technologies such as 5G, other mobile technologies such as Wi-Fi 6, and all the current incumbent services such as broadcasting, satellite, and science services. Other topics under discussion include spectrum for suborbital vehicles, spectrum for GSO and non-GSO systems communicating with Earth stations in motion, ships, planes, etc., and inter-satellite links, and many others. If you want to know more about the WRC 23 agenda items and the discussions that will take place in Dubai, You are very welcome to join the third ITU Interregional Workshop on WRC 23 preparation, which will be held at the end of September in Switzerland. This will be the final occasion for delegates to come together prior to WRC and a great opportunity to understand further the proposals of each regional group on the agenda items, issues, or topics of WRC 23. You are very welcome to join this workshop. I thank you very much for your attention.
Well, thank you, Mr. Mario, for the keynote speech. His insightful speech, I guess, that help you better understand the theme. Once again, thank you. So that brings us to the end of the opening ceremony. But before we move on to the next session, to commemorate this very special moment, we're going to take group photos. So I invite guest speakers and other attendees to come up to the stage. We are going to take group photos. Please come up to the stage. And we are taking 2 shots. For the first shot, we are going to take photos with attendees here. And for the second shot, we are going to take photos with online attendees. So online attendees, please make sure that your camera is on. Please be ready. And now this time, I invite all the speakers and attendees to come up to the stage. Thank you. Well, these are people who really work hard for the development of spectrum management in each country. So would you please give them another big round of applause? Well, thank you. Yeah, and it is the first day of 2-day journey. So for the successful conclusion of this forum for the next 2 days, how about raise your hand and chant fighting together for taking photos. Raise your hand like this. Raise hand here like this and chanting fighting. Fighting means way to go in Korean. So I will count 3. So on 3, please chant together fighting. Okay? 1, 2, 3, fighting. Thank you. Thank you so much. And for the second shot, now at this time, we are going to take photos with online participants. Please remain on the stage because we are going to take photos with online attendees. So please make sure that your screen is on. Online attendees, once again, I invite all the speakers to the stage because we are going to take photos with online participants. Online participant? Okay, give us a wave, give us a wave. Online participant, give us a wave, thank you. So, be ready to smile for the camera. 1, 2, 3. Thank you. Thank you. Thank you so much. You may return to your seat. 네, 자리로 모시겠습니다.
Please return to your seat. Thank you very much.
We need a little time to get the stage ready for the next session. So while we wait, I'll give you a quick overview of what's coming up. We have session 1 and 2 planned for you, and which will be followed by a panel discussion. And each session features 3 speakers, and each session has its own theme. So now it's time to proceed to the first session. Without further ado, let me introduce the first presenter of the first session. Our first speaker for this session is Tae-ho Lee Deputy Director of the Central Radio Management Service. He delivered a presentation under the theme of Spectrum Monitoring Process in Korea. Please welcome him with a big round of applause.
첫 번째
So I'm the first speaker of the day, and this is giving me a bit of stage fright. I'd like to extend my greetings and welcome to all of the participants of the 2023 Global Spectrum Management Forum. I will be speaking about spectrum monitoring process in Korea. I am the Deputy Director at CRMS. This is the content of my presentation: radio monitoring acts, radio monitoring organizations, radio monitoring tasks, and radio monitoring cases.
먼저 전파감시 법령에 대한
First, the goal of Radio Waves Act, the history of the act, and the structure of the Radio Waves Act. Radio monitoring acts, or Radio Waves Acts, is to promote efficient and safe use and control of radio waves, and also promote research and development on radio-related technologies, and also grow radio-related businesses and advance public welfare and benefits. Now is the history of the Radio Monitoring Act. The Radio Management Act was enacted in 1961, and in 1992 it was revised to Radio Waves Act. And in the year 2000, it had changed from regulation-focused to promotion-focused, and there was a full revision of the Radio Waves Act for the first time in 20 years. It has gone through, since the year 2000, a total of 59 revisions. Next is the structure of the Radio Waves Act. The Radio Waves Act determines the basics of radio management, including licensing of radio stations and technology standards. And it also defines articles that are assigned by the Radio Waves Act and requirements for enforcing the articles, and are also enforcement rules of radio waves. And for radio equipment rules, it defines technology standards on radio equipment based on the Radio Waves Act. Next, about the radio monitoring organizations. So the central organization would be the Ministry of Science and ICT, which oversees all of the policies on radio wave management. And affiliated organizations would include Central Radio Management Service, CRMS, and the National Radio Research Agency. Related organizations include Korea Communications Agency, Korea Radio Promotion Association, and Telecommunication Technology Association. The Ministry of Science and ICT includes 49 organizations on science and technology and 11 organizations in the ICT field. Next, the status of the CRMS organization. The headquarters includes 5 divisions, including Radio Planning and Radio Monitoring Division. And we also have Satellite Center and a total of 10 regional offices. CRMS has its regional offices take charge of radio management across each area. Now, the history of CRMS. In 1947, the post office began monitoring radio waves, and in 1983, the Central Radio Monitoring Office was established. It was changed into Central Radio Management Service in 1987. And in 2013, 2017, and also in 2008, the name has changed of the Ministry of Science and ICT. So currently we call it the MSIP, Ministry of Science ICT. Next, the tasks of the CRMS. So radio monitoring for clean radio environment and monitoring takes place. And there's also protection of critical communication networks and response to radio interference for national security, and also licensing and inspection of radio stations, and also crackdown on illegal radio equipment is taking place. Next, I would like to share radio monitoring tasks overview through international radio monitoring status. First, radio monitoring tasks overview. What is radio monitoring? Monitoring radio spectrum for effective and orderly utilization of radio resources through the removal of radio interference and investigation and enforcement of illegal radio stations. This includes detection of illegal radio frequencies, radio station monitoring, and satellite radio monitoring. So this is to establish order in radio usage and also identify, recover, and reallocate unemployed frequencies. Next, I would like to share with you the pride of the CRMS Radio Monitoring Control Center. It includes broadcasting, communications, satellite, GPS, aviation, and EMP. And it serves as command and control center for the regional offices to detect any interference and prevent interference, and works on a real-time basis. And also, there is the emergency response team for speedy response to any incidents. Next, investigation and enforcement tasks of radio monitoring. For efficient use of the radio resources, there are fixed and mobile monitoring systems in place. What you're seeing on the slide now is a fixed monitoring system. Currently, we have these fixed monitoring systems installed across the country, and they detect illegal radio stations and also unauthorized use of radio waves. It has developed through the first through third generation, and currently there are more than 90 units. And on the slide, what do you believe is the biggest difference between each generation? Of course, we go through first generation through third generation, and we can see that it measures across wider spectrum bands, and it also has come to include many other features, including GPS, to monitor over wider radio frequency ranges. So we are replacing the outdated systems, and by next year we will have them all fully replaced with the third generation systems. Next is the mobile monitoring system. So the mobile monitoring system looks at areas that are not covered by the fixed monitoring system, and also supports national level ceremonies. And there are over 20 units spread around the country, and it does plays the same role as the fixed monitoring system. And again, these previous generation units are going to be replaced with the third generation units. Next, radio monitoring enforcement work. So it identifies and investigates unlicensed or unreported radio stations for a safe radio environment. And the radio frequency quality is monitored, and if it is not up to par, there are amendment measures implemented. And if there is unauthorized change or replacement of radio equipment, then administrative procedures would be put in place. Next, protection of critical communications network and interference investigation. Interference investigation is to make use of the 26 interference investigation teams to respond swiftly in cases of interference between radio frequencies or cable TV transmission line leakage. There is also a prevention of interference on critical communications network. In the Pyeongchang Winter Olympics in 2018 and in the launching of Nuriho satellite in 2022-2023, all of this was supported by the CRMS's interference in investigation and protection of critical communications network work. And there is also regular assessment of sites for military security and disaster control and management. Next, radio frequency usage survey and radio noise measurement. Radio frequency usage survey refers to research on bandwidths with high potential demand to acquire base data to recover and reallocate frequency for more effective usage of the radio resources. And this takes place over the course of 24 hours for at least 7 consecutive days every month. 7.5 gigas. And radio noise measurement refers to measuring noise in a specific location around remote locations to acquire base data for radio monitoring and reallocation of remote locations. It takes place for 24 hours once every month. Next, satellite radio monitoring. This is to protect the domestic satellite network by monitoring the status of ITU-R, regulation conformance, and the orbit of stationary and non-stationary satellites over the Korean Peninsula. The monitoring takes place across satellites in between east longitude 55 and west longitude 160. So we have 159 stationary units and over 7,000 non-stationary units. And conformance to ITU-R regulations and also monitoring of the registration of Korean local infrastructure is done. And there's also identification of illegal satellite network radio, and there is also mediation work that works in conjunction with the ITU. Next, international radio monitoring. Monitoring international radio spectrum refers to regularly measuring reception status and quality of radio signals used by neighboring countries. And also, whether radio used by neighboring countries interferes with our communications network or vice versa, then the source of the interference is identified to resolve disputes and promote collaboration. Next, International Marine and Aviation Communication Monitoring System. This looks at the conformance to regulation of the ICAO and IMO. And in terms of international collaboration, there are regular meetings between radio monitoring organizations from Korea, China, and Japan for the smooth resolution of interference and other issues. What you see on the slide might seem a little bit different from what you are used to. This would be an overall general picture of radio monitoring based on new technology. So it will be more proactive and automated monitoring that is based on big data and artificial intelligence. So artificial intelligence based on the fourth industrial revolution technology will allow for 24-hour real-time monitoring of all bands and to provide digital public services. And with the proliferation of UAM and other digital services, we are trying to build a more advanced digital monitoring platform. The ISPs are currently underway, and by obtaining budget, the programs and initiatives will be implemented. Lastly, I would like to share with you radio interference investigation cases and illegal radio station crackdown cases. First, this was a interference that took place at a radio station for a maritime operation, the Donghae Coast Guard. The marine and aerial system generated interference was investigated in this case. At Busan Port, there were reports coming in, and we found that interference was taking place from a relay station in Donghae-si. And next is illegal radio station crackdown and illegal frequency crackdown. And then this next one is a case where we tracked down to a GPS tracker that was used for hunting the wild boar. And this is a case that is quite often found when users used unauthorized devices that are connected to illegal radio stations. And next, there was use of illegal radio frequency regarding a radio station used in leisure boats. So that was the status of spectrum monitoring in Korea, and I do hope that this will be a very helpful forum indeed for all of the participants. And with that, I end my presentation. Thank you.
Well, thank you very much for starting the forum with such an informative presentation. He provided an overall snapshot of radio management in Korea and also radio monitoring tasks as well. So once again, thank you very much. And we'll now proceed with the second presentation. This presentation will be delivered from New Zealand, and Mr. Craig Scott, the Principal Spectrum Planner at Ministry of Business, Innovation and Employment in New Zealand. He delivered his presentation under the title of The Future of 600 MHz Opportunities for UHF Mobile Communications. So let's give him a big hand.
Good afternoon to everybody, and thank you for the opportunity to speak at the Global Spectrum Management Forum today. It's an absolute pleasure to be here and to be able to speak to you. My name is Craig Scott. I am a Principal Spectrum Planner for Radio Spectrum Management in New Zealand, our spectrum regulator. Today, I'm going to give you some perspectives on the future of 600 MHz and opportunities for UHF mobile communications, along with some of our initial thinking in New Zealand. I'm going to briefly touch on 700 MHz and then take a wider look at UHF as a whole. I'm then going to have a look at 600 MHz mobile band plans and some of those opportunities that they present to us. So UHF frequencies are very important and desirable for a number of different radio applications. These include television, radio microphones, and of course, mobile applications. UHF has a good balance of favorable propagation characteristics, being able to achieve large coverage areas, being good in rural areas, while offering reasonable bandwidths. And it's for these reasons that UHF is of strong interest to New Zealand. We have very good connectivity and broadband. We have 85 or more than 85% of New Zealanders that have access to broadband fibre. We also have the key mobile bands available, including a number of bands below 1 gigahertz and a number of frequency bands in the mid-band. We are currently working on millimetre wave frequencies. Further UHF frequencies below 1 gigahertz are important and are important for providing that coverage to those rural areas, particularly those sparsely populated areas. You'll see I've put a map of New Zealand on the slide. The red colours represent our main centres with our highest population densities. All of the green areas represent less than 100 people per square kilometre. Regarding the status of 700 megahertz, in 2007, we started a process of transitioning to digital from those existing analogue television services. By 2013, this was complete, including the restack and clearance of 700 megahertz. Since 2014, the spectrum has been available to 3 mobile network operators that now have more than 3,500 base stations. At this stage, these networks in 700 megahertz are currently operating 4G LTE, but they could be transitioned to 5G NR in the future. We have technology flexible conditions, so it is a commercial decision for those MNOs to make, and it does not need our regulatory intervention. Looking at the UHF band, or particularly around 500, 600, 700 megahertz as a whole, we have land mobile radio systems, including emergency services, below 502 megahertz. We never actually had television down to 470 megahertz like some other countries do. We have our current digital television from 502 to 622 megahertz, and this supports 4 to 5 multiplexes carrying high definition programs. That move to digital did allow us to have efficiency gains and free up spectrum. Also, under analogue, we had thousands of sites, which did consolidate down to 30 sites under digital. Digital television in New Zealand provides coverage to the main population centres. The rest of the country is covered by satellite delivery of television. There is a little bit more capacity in the spectrum we have available for television today, with approximately potentially 3 to 4 DTT multiplexes that could be added. We do see digital television as being relatively stable. Since our restacking in 2013, we've seen very little changes in the band. However, we are still continuing to see a strong viewership of the current programs in digital television, and we do expect this to continue. However, there won't be much, we don't expect to see much growth in linear broadcasting. We're seeing quite a strong increase in on-demand offerings, with many of the current broadcasters offering their own over-the-top demand, on-demand services, of course supported by the high level of broadband rollout in New Zealand. We do have other users in the band, including radio microphones, which operate under general authorization or license exemption. And they are an important user that do work in all of those gaps between 500 and 600 megahertz. 600 megahertz has been fairly popular with the radio microphone users, as it is relatively empty at this stage. We also have some television white space use in the 500 megahertz band, but this has been fairly limited. So when we turn to potential options for 600 megahertz band plans, there are I guess 2 choices on the table that we can look at. The first is the 2 by 35 megahertz band plan, or 3GPP band N71, which is used in some countries, namely North America. I guess the second option that we have to look at is the Asia Pacific 600 megahertz band plan, known as 3GPP band N105, and this provides 2 by 40 megahertz, so that's an additional 5 megahertz paired on top of the N71 band plan. Over the last couple of years, there have been some studies undertaken in the AWG, where we have played a fairly active role in those studies and discussions. These studies looked at 2 different band plan options. These were known as B1 and B2, shown in the diagram at the bottom left of the screen there. And this was to provide that 2 by 40 megahertz band plan. The studies went and looked at a number of different aspects, including minimizing guard bands between mobile and DTT through undertaking studies in a Monte Carlo analysis. In the duration of this work, there was a lot of involvement from the industry experts, regulatory experts, and a lot of liaison activity between AWG and 3GPP in an iterative process. Finally, the AWG settled on option B1 for the APT 600 megahertz band plan, and this work was concluded with the revision of Report 79 in September 2022. In parallel to this work in AWG, there was a body of work undertaken in 3GPP. As mentioned, of course, there was regular liaison between AWG and 3GPP on this band plan. First, 3GPP undertook technical studies and feasibility studies on options B1 and B2, and this was captured in the report 38.860. Following all the considerations among the experts, option B1, of course, was decided. And then this moved on to normative activities where the core specifications were completed in November 2022 and the performance specifications in April 2023. And that made the N105 band plan. The work also considered band combinations that N105 could work with. And for example, this includes the combinations where N105 can work with bands 1 to 7, band 78, 257, and 258. So managing the radio spectrum is always a difficult balance with a number of challenges. Regulators need to balance up the different uses and make decisions on what will provide the greatest benefit to their citizens. This, of course, may be coupled with some of those broader policy objectives, such as improving rural connectivity. There are different coexistence considerations that need to be worked through on the 600 megahertz mobile band plan, including coexistence with DTT receivers. One issue was thinking about those overlapping channels. So we do have a couple of overlapping channels at this stage. And of course, those adjacent channel considerations and coexistence within an area. These considerations will vary from country to country. For example, we use DVB-T1, and that is on an 8 megahertz channel plan. Of course, different countries have different technologies for TV, and of course, cross-border issues. Not so much of an issue for New Zealand, but a consideration for many countries. Today, radio microphones are operating under general authorization in those gaps between the spectrum. And if 5G were to be used, those gaps would be reduced. Further thought needs to be given on spectrum availability in UHF and potentially other frequency bands so that those major events such as sports matches, concerts, and other production events can continue to be supported by radio microphones. There still is a question about what is the best band plan to adopt and whether that's the 2 by 35 megahertz N71 band plan or the 2 by 40 megahertz N105 band plan. And of course, there is a question about UHF as a whole, including 500 megahertz. While it is a good point, in our view, it'll be several years before a clear picture emerges on the future of 500 megahertz. And in the meantime, we may have missed an opportunity with 600 megahertz mobile. So from our side, we are still in our preliminary stages on 600 megahertz in New Zealand and are studying these initial considerations. So I thank you all very much for your time today and giving me the opportunity to present today on 600 megahertz and share some of our perspectives. Thank you, everybody.
Thank you. Thank you, Mr. Scott, for taking your valuable time to share your knowledge. And I guess many of our attendees gained so much insight from your presentation. Once again, thank you very much. And now we come to the last presentation of this session. Please welcome Mr. Ki-Hong An, Manager of Telecommunications Technology Association. He delivered his presentation titled Spectrum Management in ITUR SG1. Please welcome him with a big round of applause.
네, 안녕하세요. 전 TTA의 안기홍 책임이라고.
Good afternoon. I am Kyung An from TTA.
Everyone and good day to all. My name is Ki-Hong Han from TTA. And thank you very much for inviting me and giving me a chance to present here at GSMF 2023. Today, I will briefly introduce ITUR SG1 activities, especially on Korean delegation activities. I'll start with some brief introduction on ITUR and SG1, and then I would like to share latest development of recommendation and reports conducted by each working party. And then lastly, I will conclude my presentation with the future overview of study group 1. This is structure of ITUR, and the important point in this structure is that ITUR is under the radio regulation circumstances, and this radio regulation ensures the availability of the frequencies provided and assists in the prevention of harmful interference between the radio service of different administrations. Obviously, this has strong impact on domestic law also, such as Radio Act of countries. And this regulation can be revised through the WRC based on the study conducted by each study groups. There are 6 study groups under the ITUR sector, and each group is responsible for certain WRC agenda item. To figure out the WRC agenda item, SG does study on question and provides recommendation toward questions. Among them, SG1 covers spectrum management. This group composed of 3 working parties, 1A, 1B, and 1C. Among the 6 study group in ITUR, I will focus on the study group 1. Study group 1 provides spectrum management principles and techniques, general principles of sharing, and spectrum monitoring as well. So main objective of ITUR 1A, 1B, and 1C activities are to develop and maintain ITUR recommendations, reports, and handbook relevant to spectrum engineering techniques, spectrum management fundamental, and spectrum monitoring. And next slide, I will introduce one of topic handled by Working Party 1A. As you can see, there are several topics, and then they normally related to the spectrum engineering techniques. Also, there is collaboration with other SDO like IEC, CISPA, since 1A is also interested in EMC-related interference. and unwanted emission, visible light for broadcast communication, etc. However, for last 10 or 20 years, wireless power transmission has been one of the main topics handled by Working Party 1A. And there are several work items ongoing related to WPT, and one of them is revision work of recommendation on guidance on frequency range for operation over a non-beam wireless power transmission system for mobile and portable devices. The objective of this recommendation is to provide guidance to minimize the impact of using WPT technologies on radio communication services, and saying that WPT devices should not cause any interference to recommendation service in any frequency band. As a simple solution, this not to cause interference, the recommendation says to utilize frequency band designated for ISM applications. Also, the recommendation gives guidance on frequency ranges for non-beam WPT systems. Compromised frequency ranges in Table 1 should be considered to be added subject to the related impact analysis and to the agreement of administrations for the revision of recommendation. However, the meeting held this year, 2023, reached to the consensus that 1A cannot conclude the frequency range table before the impact study is completed. For example, there is strong view on necessity for an interference impact study on 315 to 405 kilohertz range for WPT system and AM broadcasting. This recommendation is closely related to, the last column indicates this recommendation is closely related to the report ITUR.SM.2448, which is impact study report. And Working Party 1B covers spectrum management, methodology, and economic strategies. Currently, there are only few work items ongoing in Working Party 1B, and one of them is methodology for assessing or predicting spectrum availability. In 2019, Korean delegation proposed the necessity of study on spectrum availability issue. And the discussion with the group, question number 241, which is methodology for assessing or predicting spectrum availability, is approved. Based on that question, the technical report project has commenced. Briefly introducing the background of this work, the work on methodology for assessing or predicting spectrum availability has begun after the question 241 was approved in 2019. Like I mentioned in previous previous slide, Korea delegation proposed in this new work item because as a part of 5G spectrum planning, without it is really significant to utilize and measure the spectrum demand based on some technology analysis. In this report, the spectrum is classified into 3 types. First one is exclusive use of licensed spectrum, and is the type licensed owner have the exclusive right to use the spectrum. And second is shared use of licensed spectrum, is the type secondary users or potential license purchaser uses the licensed spectrum without the license. And third is a shared use of unlicensed spectrum. It's the type spectrum shares with other radio service, such as Wi-Fi and Bluetooth. This report discusses criteria information and methodologies for assessing or predicting spectrum availability for each different types of spectrum use. and introduce technical approaches that improve spectrum availability. And this diagram explains where about the criteria and required information of the report. Among the 3 types of spectrum, I brought exclusive use of licensed spectrum as an example. Spectrum demand is the main factor to be considered, and the criterion for assessing spectrum availability is established by comparing spectrum supply and demand. Could you? Oh, thank you. And usually, spectrum supply is given in terms of spectrum amount, such as bandwidth, and spectrum demand is estimated in terms of information amount, such as traffic. And for comparison, information amount and spectrum amount need to be translated into each other. And this transformation is based on factors like spectrum efficiency, etc. After the translation, spectrum supply and demand can be compared. With that concept, we can proceed methodology how to assess the spectrum availability with the 4 steps. 1, spectrum supply estimation. 2, spectrum demand estimation. And 3, transform between spectrum amount and information amount. And 4, comparison of spectrum supply and demand. More details about the methodology procedure and those for other spectrum use like unlicensed, you can find them in working document attached to Chairman's report of 1B. Spectrum 1C is about spectrum monitoring. The working party studies on method and techniques used in space radio monitoring, EMF measurement to assess human exposure, and spectrum monitoring evolution, such as drones and small sat. One ongoing work item is in Working Party 1C is spectrum monitoring evolution. With the rapid development of technology such as big data and AI technology, spectrum monitoring has tremendous development by applying those new trends. With brief mentioning the background and progress of this report work, in last year, 2022, Korea delegation proposed contribution to revise the recommendation SM.1537, which is automation and integration of spectrum monitoring system with automated spectrum management. The Working Party 1C chair and meeting made consensus on making new report rather than revising the recommendation 1537. So this year, 2023, Korea delegation proposed the first draft of the new report, SM.AI and Big Data. This report applies new trends in data science, including AI and big data technologies to the automation of spectrum monitoring. This report also compares the current reactive and ad hoc spectrum management approaches to next generation approaches like that are proactive, autonomous, and data-driven by using AI and big data. This big data spectrum monitoring solution, as shown in figure, provides an intelligent-enabled monitoring network, a central database layer, and an application layer for fine-grained monitoring and enforcement of the electromagnetic spectrum covering pretty much every frequency spectrum. This report mainly focuses on utilizing spectrum big data for optimizing radio resource and exploring temporal and spatial spectrum informations impact on resource optimization, and emphasizing the need for a large-scale spectrum monitoring system, and also emphasizing the importance of uniform rules and measurement standards in integrating data, concluding with the promise of trustworthy spectrum data analysis for accurate and reliable collected data. We have briefly reviewed several ongoing issues under the Study Group 1, and the next Study Group 1 meeting will be held June of the next year. It is expected that new work for discussion on big data, machine learning, and AI applied to spectrum monitoring and management will be important for moving forward. And next year, the working document on the report will be elaborated, and this will be facilitated by interest and participation of many other administrations. We believe that GSMF will play a significant role in international cooperation and trigger collaboration, communication, and coordination. And also, I believe this collaboration will bring up to the next stage of many work items ongoing in ITOR. Thank you very much for your attention, and this is the end of my presentation. Thank you.
Thank you. Thank you very much for your presentation, Mr. Arn. With that, we come to the end of the first session. From now on, we'll have a short coffee break. Coffee outside, please use this time to network each other over coffee, and I recommend you to enjoy the exhibition in the lobby. Thank you, and we'll resume the second session at 3:30. So please arrive here at least 5 minutes before. Thank you very much. Welcome back from the break. Now we commence the second session. At this session, we have also 3 speakers lined up for you. And at this session, we have shifted our focus to emerging spectrum technologies. Well, without further ado, let's introduce the first presenter of the session, Dr. Jin-Young Hong, the Deputy General Manager of Korea Airports Corporation, delivered his presentation titled Development of Navigation Facility for UAM and Drone Measurement System. Please welcome him with a big round of applause.
예, 안녕하십니까.
Good afternoon. I am Jin-Young Hong from KAC, Korea Airports Corporation, and I'm going to talk about the development of navigation facility for UAM and drone measurement system. The photo that you're seeing is a facility for the safe air navigation. So it tells the distance and the angle related information based on the RF signal. And then the drone that you see is called DIVA in our corporation. So this is an analyzer for the spectrum or the signal. So all the spectrum will be received and measured in these facilities. So the topic that I'm going to talk about include DIVA overview, development and utilization status as of now at our airports, and procedure and case studies and research that are now being done overseas. And then last but not least, I will talk about the UAM national R&D status. Currently, UAM R&D project is underway, so that's why I cannot tell you every single detail. So I will just briefly touch upon this R&D project. So we are in charge of 14 airports across Korea for operation and maintenance. And then the operators on site are there, and we have many different air navigation facilities, and these operators are working on the runway, as you can see from the picture, as well as the rooftop of airport terminal and near mountain top. So they measure spectrum to determine whether they are okay or not. But as you can see at the bottom, on the ground, if we measure the spectrum, then the signals that can be measured between aircraft would be different from what is measured from the ground. So that's when the problem, or I mean the issue happens. So this is the flight inspection facilities owned by the Ministry of Land Infrastructure and Transport. So we inspect the flight related information on 2 aircrafts that are available in Korea. So with these 2 systems, we test and measure and inspect all those aircraft that are in operation in Korea. So we operate this air navigation and flight inspection and etc. But to increase effectiveness, we introduced the drone system in 2016. So we started to develop in 2016 and the commercialization is completed. And we are also working on not only Korean project but also the overseas project. So let me show you a video clip about the DIVA system of our corporation.
While a plane is in flight, navigational aids ensure safety by transmitting signals into the air and providing the information the aircraft needs from the moment it takes off to the moment it lands. Types of navigational aids include the instrument landing system, which consists of the glide path that provides information on the landing glide path of 3 degrees, and a localizer that guides the aircraft to the center of line of the runway. The VOR, which provides the azimuth, which provides positioning information for military aircraft. In the past, these navigational aids were operated by personnel who used measuring devices on the ground or on a rooftop to check transmitted signals. The range of the signals to be measured did not reach to the air by this method. In order to overcome the limitations of ground-based checking, since 2016, Korea Airports Corporation has been developing the drone-based glide path checking system called DIVA. The core technology of DIVA lies on the signal measurement systems for navigational aids and its portability that easily equipped on a drone. These compact, ultra-lightweight measurement systems can be mounted on any drone and can check and analyze information from the localizer, glide path, VOR, and TACAN. KAC has registered 4 patents for this technology and received CE certification for its signal measurement systems. These signal measurement systems collect and analyze navigational aid signals while in the air and transmits the data to monitors on the ground. Drone-based checks allow for faster checking than ground-based systems by eliminating the efforts to move and relocate to multiple checking stations. It is also available to receive 3-dimensional in-air transmission data, which leads to more precise and meticulous check. The drone check can be done as a way of pre-inspection and prevents the additional flight inspection by the government that is time and money consuming. The DIVA system receives RF signals in the air using the navigational aid antenna. Then, the signal measurement systems analyze the signals and convert them into data, and the measurement data is transmitted to the ground. Next, the measurement data is sent to analysis terminals via a ground station. The analysis terminals can use proprietary software to analyze measurement data signals in real time. The first step for creating a flight path for navigational aid checks using a drone is inputting data from sources such as flight information publications. The path generating program is used to make drone flight course as KML file, and Google Maps check for any errors. Finally, the automatic flight path for the drone is uploaded and reviewed. There are a total of 4 flight paths, depending on the navigational aid. The first is the process for checking the localizer, called the approach level run orbit check, which inspects whether the signals for the structure and course of the approach slope provided by the localizer are normal. The second is the orbit check, which checks whether the transmission signal for the clearance of the localizer is normal within a range of 35 degrees, left and right. The third is the approach level run flight method, which checks whether the course and clearance of the glide path's approach slope are normal. Next, in-air transmission signals from the VHF omnidirectional radio range and the tactical air navigation system are analyzed by drones, performing remote flight around the two devices. Korea's DIVA system can also simultaneously check two flight facility systems, allowing for faster and easier inspections. These drone flights can be used to check items such as the structure, course width, symmetry, modulation, alignment, identification, and RF level on course. For a straight line localizer flight, DDM 0 microampere can be measured on course, and the structure can be used to check alignment and centerline true bearing. When checking the localizer, the width point of the transmission signal can be checked from a specific point mid-air. This point shows the width point of the localizer and has a DDM value of 150 microampere. When checking glide path level run, the width point of the transmission signal can be checked from a particular point mid-air. This point shows the width point of the localizer and has a DDM value of 150 microampere. When checking the glide path approach, the DDM 0 microampere on course can be measured, and the safety of the path structure can be inspected. After the flight has been concluded, a report is automatically generated and the check is completed. The localizer result report provides the analyzed values of transmission signal checks, average of the modulation, the minimum, the maximum, and power. The report also shows the modulation degree of the ID signal, the code course, the frequency of the clearance signal, and information on the precision of the drone flight. In addition, graph values and the capture point are also analyzed and displayed. The localizer clearance check report shows the modulation of the localizer signal at each angle, as well as the power values and the analysis values for the signals in general. This report also shows analyzed data on the course, the frequency of the clearance signal, and information on the precision of drone flight, along with graph values and the capture points for each category. The glide path result report displays the characteristic value and modulation of transmissions, the measurement values for power, the frequency, and information on the precision of drone flight, along with graphs of the measurement values. The VOR result report allows users to check transmitted values such as the azimuth error, modulation, FM index, and power, as well as the graphs for each category. Likewise, in the Tekken result report, users can view transmitted characteristic values such as the azimuth error, modulation, number of squitter, and power, as well as graphs for each category. In this manner, drone checks to provide information identical to the information included in government flight checks and produce highly precise graphs of the results. In addition, the DIVA system is also equipped with a spectrum analyzer function that measures in-air transmission signals in the form of a frequency spectrum. KAC has now succeeded in developing technology for checking DME. And our technology is the first in the world.
보겠습니다. 예, 그 다음은 계속 저희
Thank you very much, because the rest of the video clip is about what we have done well, like our achievements. So when we use our DIVA system, and we can operating it on site. some of the slides are duplicated, so I will skip them and then I will focus on something that is interesting related to spectrum management. So I will skip these slides. And if you look at this slide, well, DIVA system is well quantified, so I will skip them and then I will tell you some special feature of DIVA. So first of all, we can detect interference signal. On the left, you see a red line, and then if an aircraft approaches, then it will follow this red line. So it will land following this red line, and our drone, DIVA, will also follow this line and then will detect the signal. And if you look at the graph at the bottom, the signal bumps from -300. So reds are what are actually accepted by the signal detection. And then we got a complaint from a pilot because most of the aircraft land based on the automatic system, based on the automatic gauge. But if aircraft can land, well, the spot will be -300. The wheel will touch upon the runway at the -300 point, and then at that moment, the automatic gauge system will be was released, and that's what the pilot was complaining about. And then we wanted to know what actually happened, and then we measured with drone, like you can see here. The signal was we detected the interference signal at -300, and then we can also see the spectrum in real time. And at the top, +1 kilometer is like about 1 kilometer away from the wheel touch point, and then the localizer, the system was well demonstrated, as you can see. So there was no distorted signal and no interfered signal here. But if you look at the bottom, you see -500 meter, and then if you see the graph, you can see the just typical spectrum that you can usually measure. So there was no interference. So we judged that at a certain point, the signal was shaken, maybe because of the reflection wave. So that's what we thought, because the signal was interfered only at that point. So this is the runway. So from, you can see from number 1 to 5. So for the different height, we alter the lines, as you can see here, and then we tested the flying of many different drones like this. And then our focus was that when the reflection meets with the aircraft flow, then the light would be, or the signal would be distorted. So that's why we tried many different angles and the distance. And then this was registered as a patent in 2020, and then we also have published a study paper. This is the result of our test. You can see that the shaken or the interference signals were demonstrated on the map, as you can see. And then if you connect the red lines, and at the end of the yellow line, you can see that there are reflected waves, and then they were reflected, and then actually at there, the hangar was like aircraft shed was placed there. So So when we try to find the causes, we usually use a simulation, and then at this point we use many different types of drones by changing some angles, and then by doing so we could find out the causes of the distorted or interference signal on the runway. And then we provided 5 sets to our army, especially to the Air Force, and then we are going to provide 1 set to the MOLIT, Ministry of Land, Infrastructure and Transport of Korea, this year. And then this is from last year. So we won the consulting project from Colombia, and then we are currently working on a demonstration and we have completed the demonstration and technical consultation on Neve's inspection by using DIVA in Colombia. So this is also another special case. These are the localizers made of metal, and then you can see the location of the localizers and runway. And then the Colombia Aviation Agency asked us that they could detect some interference signals, and what they thought were that there was a new airport terminal, and there is a hill here, and then the forest was very thick near there, and then the signal was reflected there. So that's why maybe the interference signal was happening in the localizers. And then after those opinions, we flew drone like this. So the wave is coming from here, and the aircraft was approaching in this way, and then drone was flying in this way. So the reflected waves were not impacted by our testing flights. And then the result is shown on the slide. There was supposed to be a graph, but it's now gone. Yes, there it is. There you go. So this is a graph. So it's kind of a, maybe it's kind of a hidden card. So this is our measurement. You can see that there are some gaps in between, and then you can see some fluctuations at the end of the wave, and there was no symmetry. So this means the buildings or the forests were not the ones, not the causes of the reflection. So that interference occurred because of the localizers specification themselves. So we delivered this consultation to Colombia, and then you can see that the Colombian broadcasters even covered this issue. So we are doing well with the procedure, so I'm going to skip this slide as well. So this is a GUI that is being operated on the ground. So measured values will appear in real time, and at the same time you can see the spectrum in air that is being measured in real time. So if there are any interferences, then as we know the spectrum that is used by our air navigation facilities, we can check the status right away in real time. I will skip these slides as well, and this one as well. So the air navigation system are checked by drones in R&D project, and there are so many projects going on across the world, and I believe that Korea is taking the lead here, and Germany, Switzerland, and Spain are also working on these cases. I will skip these slides as well. So the DIVA system has 4 patents already registered and 5 papers published. And then there is an international organization, ICAO. So there are 3 ICAO IPs registered. So last week there was an Asia Pacific ICAO meeting. We shared our presentation on DIVA. So we have 3 information papers submitted to ICAO. And then in last week's meeting, our topic was chosen as a main agenda items. So when we go to Montreal, where the headquarters of ICAO is located, we will make another presentation on DIVA. So this is the end of my introduction about DIVA. And then from here, I will talk about the UAM RF ground-based navigation system and its R&D status. So it was designated as a national R&D national project from last year, and it's now underway, as I said, so I cannot share details, but I can just explain about the overview. So KAYA is the host organization for this UAM project. If you see the left bottom, you can see the UAM RF ground-based navigation system. So this is type number 1. So it was completed this year, and from November, it will be tested outside our facility. And then every module is now tested by responsible department. And then in the middle, you see UAM RF ground-based navigation system type number 2. And then if we complete this, we will test it near Hangang River in Seoul. And then on the right, at the bottom, you can see UAM mounted signal analyzer. Here you see signal configuration from the navigation facilities. You can see on the left and on the right. So we need 2 facilities as one set. And this signal configuration shows that if there is a Han River in the middle, then we will put Han River in the middle, and then the navigation facilities will be located on the left and then on the right respectively. And then signals coming from these facilities will cross each other, and that's going to be the air route. So there are 1, 2, 3 or 4 lanes on the highway, and then there are like lanes at the top and bottom, and etc. So just like those highways on the ground, you can also make such routes in air as well. So this is an example of a UAM route configuration over Hangang River. Our goal is to make UAM run on the highway from the takeoff until the landing. So this is the end of my presentation. So thank you very much.
Thank you for a valuable presentation, Dr. Jin Young-hong. He provided an account of DIVA system and how it's being used in various scenes, and also offer a brief explanation on UAM project. Thank you very much for your information. And now let's move on to the second presentation of the second session. Dr. Sang-Yun Lee, team leader at Korea Communication Agency, delivers a presentation titled Local 5G Status and Use Cases in Korea. Please welcome him with a big round of applause.
네, 안녕하세요. 저는 방금 소개받은
Good afternoon. My name is Sang-Yun Lee. I am team leader at Korea Communications Agency, KCA. I would like to speak to you today about local 5G or EUM its status and use cases in Korea. So this is the order of my presentation. I will begin with an introduction of local or 5G, and then the status of local 5G in Korea, and network solution status, and then local 5G use cases. So local 5G or 5G is a customized 5G network for specific purposes. So for specific terrestrial areas or buildings, 5G networks are used, and those are called local 5G or 5G. In December 2021, this local 5G was named and stands for the well-known 5G feature. So it takes the first letter off of E and BB, URLLC, and MMTC, so EUM. And the Korean word EUM also means connection between humans and objects. So EUM 5G, it can be akin to private 5G or local 5G or campus 5G or non-public networks. So there would be 3 cases where local 5G would be needed to be introduced in Korea. That would depend on who provides the service and who uses the service. So there would be 3 different types. Type 1 would be a private network. So the service provider and the service user are the same entity. The service users are usually the employees or people within the service providing organization. And in this situation, the user would be the organization, and they have to register as a private network builder. And they would get radio station licenses with frequency designation. The second type is a little bit different in that the service users are not only those who are affiliated with the service providers, but also visitors and third-party users. So in type 2, the service can be provided to not only those within that organization, but also visitors and the public. And so they would register as a telecommunication operator and obtain spectrum assignment. Type 3 would be similar to type 2. It says on the slide third-party operator as the service provider. So this would be a company that specializes in providing these services. So a company that specializes in 5G services to its client companies. So when we're talking about mobile telecommunication, it would be providing to subscribers, but third-party operators under type 3 would be providing 5G services to its client companies and entities. And again, they have to register as telecommunication operators and have to obtain spectrum license and spectrum assignment. I seem to have been talking with the table of contents slide. Sorry about that. Now moving on to the next slide, I would like to share with you the available spectrum bands for local 5G, 5G. We could use 2 different spectrum bands. One is known as N257 band, which would be 28 gigahertz. And that amounts to 12 blocks of 50 megahertz each, amounting to 600 megahertz. And the next is the N79 band, which would be 4.7 gigahertz. So there would be 10 blocks of 10 megahertz each, amounting to a total of 100 megahertz. Next is how or the status of local 5G implementation in Korea. And those would be type 2 or 3 service providers. As of July 2023, we have 13 local 5G service providers, as listed on the slide. If you look at the list, we have Naver Cloud, and at the bottom, we have Megazone Cloud. So we have the cloud service providers, and then we have LG CNS and CJ Olive Networks, and Hyundai Auto Ever, which would be system integration firms. And then we have SK Network Service, KT MOS, and then NewGens, which are companies that specialize in building telecommunication networks. And then we have Sejong Telecom, which is a telco provider. And then we have LS Electric and Wizcore, which would be smart factory providers. So what we can tell from this slide is that telco operators would mostly be focused on mobile telco operators. However, we have cloud service providers here. We have SI companies. We have smart factory feature providers. And so we can see with the 5G, there are so many different kinds of service providers who can enter this industry. And on the next slide, we have the private network builders, or in other words, the type 1 providers. So in the energy sector, we have KEPCO, and then Korea Hydro Nuclear Power, KHNP, and then also K-Water. We also have the government agencies such as the Ministry of Public Administration and Security. So we have utilities and public sector entities which have to build large-scale networks, and they often choose to operate their own private networks. Next, I would like to share with you the status of network solutions in Korea. EUM 5G basically it doesn't service for a very large number of subscribers as a mobile telco operator would. So they would need specific equipment and facilities and solutions. So in Korea, we have a variety of lightweight equipment and solutions that provide local 5G equipment. For a specialized network, they should only cover a certain area, so that's why we need lightweight cores. And we have core vendors who are able to satisfy those demands, like Iluon, Flectory, HFR, Samsung, and UAngel would be some examples. And radio access networks also are required. More lightweight solutions are being provided by companies such as UCAST and HFR and InnoWireless and Samsung. And in terms of terminals, there might be a wide variety of form factors that are required. So for mobile telco, we think about tablet devices and mobile phones, but if we go to the industry, we might need a wider variety of form factors in terms of terminals. So there are diverse terminal form factors that are being developed by AM Solutions, Bluebird, and Wurinet, and LG Electronics. Next, I would like to share with you some use cases of 5G EUM. EUM 5G, local 5G, brings together the mobile technology and 5G technology, and also the advantages of private networks. So, in other words, the strengths of 5G technology and private networks are brought together to provide specific use cases for each vertical domain. So to focus first on 5G mobile technology, because this is mobile telco service, it's very mobile. So it provides wider mobility and reliability compared to wired or Wi-Fi networks. And meanwhile, compared to wired networks, because this is mobile technology, of course it's more mobile, but at the same time, if a production network is built on a wired network, if we're trying to do flexible, elastic production, then there will have to be capacity adjustments. And each time deploying wired lines and then taking them away, that would be very expensive, and it would also require a lot of effort. However, we can replace it with mobile technology, so that's quite useful in that context. And also, using 5G would be much more better for performance, reliability, and handover. And if we're using more terminals and more devices, then devices will have to compete with each other to get on the Wi-Fi network. And compared to that, 5G can provide much more reliable services and performance. Next, eMBB. So this is one of the important characteristics of 5G. It provides ultra broadband capability. So video-based applications, virtual reality, augmented reality, that can run very smoothly on 5G. Then URLLC, ultra reliable and low latency. For real-time control or mission-critical services, reliable performance can be guaranteed by 5G. And in terms of MMTC, or massive machine type communication, in manufacturing situations, a lot of sensors are built on a wide network, and that could work very well with 5G. And then we'll also talk often about digital twin. What is in the physical world is mapped to what is in the virtual world, and that would require a large-scale sensor network. And 5G network could be very useful in that regard as well. Next, the characteristics of the private network. The biggest strength of the private network is that it is customized depending on the demands of the user. For example, we have a place that works on a public network, but if a public mobile telco network would be focused mostly on downlink, and the capacity is mostly concentrated around downlink operations. However, if we're trying to use visual and video content on the field, then there would be demand for a lot of uplink operations. And customization can be possible to address that discrepancy. And then we have data security. So sometimes at home, people set up surveillance cameras, and sometimes there might be unexpected incidents related to those surveillance cameras, and that would be a very serious issue if it would be in the context of a company. For example, if data within a company is leaked outside, then of course that would be something very serious. And so that's why some companies are more inclined to build private networks for better security. So with the characteristics or strengths of 5G mobile technology and private networks, a lot of different services can be provided. And here I was focusing on the telco aspect, communication aspect, but AI, big data, and cloud, and more advanced technologies could work together with 5G, local 5G, to serve demands in manufacturing, smart city, safety, healthcare, entertainment, logistics, digital twin, and transportation. So there are so many different sectors or areas where this could be useful. And another thing I would like to mention here is whether it's EUM 5G technology or other communication technology, we always consider its potential spread to different verticals. And if the communications industry is spearheading this effort, the manufacturing or healthcare sector might have different demands from what the communication people are trying to develop. And I will later speak about different use cases, but when we are building these use cases, it is very important for us to understand the needs of each industry and sector and how to address those needs with our technology development. Next, there are other examples of use cases. First is medical service and healthcare service. In particular, within the hospital, there are certain services that may be provided based on 5G, local 5G EUM. First is non-face-to-face collaborative medical examination. Within the hospital, when you're treating a patient or making a diagnosis, specialists of different areas would come together for collaborative work, and this technology could be very helpful in that context. And then there is augmented reality aided surgery. So MRI footage and data on the site of operation, all of these have to work together when surgeons are doing their operations. And in terms of autonomous mobile wheelchairs, we can see wheelchairs are here and there in hospitals, if you go to big hospitals, and autonomous mobile wheelchairs would be much easier to manage and have them not be cluttering the hallway. And in terms of energy, as you can see on the slide, we have a quadruped walking robot at KEPCO for their stations. They're actually using quadruped walking robot guards. And next, we also have the airport needs to detect different risks, such as risk of fire or approach of unidentified objects, and also to guard against birds on the runway. Because birds can obstruct aircraft in flight, those have to be detected beforehand. And also logistics movement within the airport will be addressed with autonomous vehicles based on 5G local EUM technology. The next slide on use cases would be smart city use cases and industrial safety use cases. So this was also based on a pilot project in Korea. There were safety sensors attached on here and there on bridges in Busan. And we also had digital twin built to predict and monitor and prevent any risk factors. And under that, we can see the 360-degree camera, mobile autonomous camera, traveling the streets to detect anything that is unusual. Thermal imaging camera and other visual data is used. And also it would work with artificial intelligence to detect if there's any abnormalities. And then on the right-hand side, we have the industrial safety use cases. In manufacturing context or construction context, we see a lot of accidents taking place. And to prevent those accidents, the operator would be given with wearable devices to detect and prevent falling from heights. And also based on closed-circuit cameras, abnormal activities or movement would be detected. And there are also a lot of equipment and devices that are used on industrial sites. So those devices would be monitored constantly. And if there is any breakdown or if anything goes out of order, then any such cases would be predicted beforehand. To do predictive maintenance. The next slide on use cases would be using millimeter wave spectrum or 28 gigahertz wave spectrum. It doesn't have wide coverage, so it would be very localized use cases. However, using ultra-wide bandwidth, it can provide very high throughput. So 28 gigahertz is something very suitable for EUM 5G. And there are some use cases that actually did use the 28 gigahertz wave spectrum. First is immersive real-time attraction service. This was also based on a pilot project. At Lotte World amusement park, there are some rides or attractions. Cameras and sensors are attached here and there on the rides, and signals are received remotely to provide a virtual experience of the same ride. It provides it requires very high resolution video data and different types of data. So that's where the 28 gigahertz wave spectrum comes handy. And next is AI vision-based robot control in warehouses. On the logistics industry, we can see many different robots, AMRs, and forklifts at work. And the logistics sensors environment also have to be controlled, managed, and monitored. And that would require a lot of sensors, which would generate a lot of data, massive amounts of data, which would require or work very well on 28 gigahertz spectrum. The next slide on use cases is about digital twins, smart agricultural products. First, on digital twins. Digital twins are not an application per se. It's actually sort of a foundation to deliver application services. So if a AMR, autonomous mobile robot, is at work, sometimes it would work based on a digital twin. In other words, a physical building's inner spaces would be virtually replicated on the cloud, for example. And the AMR would be able to locate itself with very high precision based on content that is coming in through camera onto the cloud. So it would match up the data with the digital twin data to be able to locate itself. So that kind of service and technology could be provided. And in the middle, you can see a robot which has installed a 360-degree camera that enables digital twin technology. And next, we have agricultural products processing. In agriculture, 5G, people always think about really high-tech industries when we're thinking about the use of and 5G technology. However, in the agricultural sector, because there's a shortage of manpower there's a lot of demand for these kind of advanced technologies. And there's something called APC, which stands for Agricultural Products Processing Center. So this is where the agricultural products are harvested and brought into the processing center and packaged and sent out, shipped off to the end customer. All of this is going to be automated based on 5G technology. A lot of this is already automated, like washing the produce or measuring the size or the weight or the sugar level. A lot of it is already quite automated, but one thing that is hard to automate is checking the appearance of a produce. For example, if there are any marks on a piece of agricultural product, that has to be done using vision technology, and that can be addressed using 5G. And here on this slide, this shows 11 pilot projects that were initiated in 2022. Some of this has been covered in my earlier slides. Across 8 service sectors, 11 pilot projects were begun in 2022. The logistics project was spearheaded by Gyeongnam Robot Foundation, and in medicine, we had Bundang SNU Hospital, Mokdong Ihwa Women's University Hospital, and Samsung Seoul Hospital. And in terms of security, Korea Industrial Complex Corporation was in charge of that project. And next, for water management and then energy, we had K-Water and KEPCO, and Korea Hydro and Nuclear Power, KHNP. And manufacturing, we had Korea Aerospace Industry taking initiative. And in terms of culture, the Latte World, the amusement park attraction project was managed by the Smart Media Promotion Association. So that's all I have for my presentation. Thank you for your attention.
Well, thank you very much. He walked us through the definition of local 5G and its status, and also network solutions with various use cases. Thank you very much. This is time for a panel discussion, and all the speakers present today will join this panel discussion to go deeper into the theme. So I'm quite sure their discussion will help us better understand the theme, and your participation will make this discussion even more fruitful. So I kindly ask you to stay with us until the end. So for the discussion, I'd like to introduce today's moderator, Il-Gyu Lee, professor at Gongju National University. He will lead the discussion as a moderator today. Professor Lee has worked in extensive areas related to OLED development of WCDMA, mobile WiMAX, and radio monitoring system for nearly 10 years at the Electronics and Telecommunications Research Institute. Furthermore, he has served as the vice chairman of ITUR SG1 since his appointment during Radio Assembly 15. So, I'll pass over the microphone to our moderator.
Thank you very much for your nice and kind introduction. Okay, this is a panel discussion time, and for the sake of saving the time and effort, I'd like to make some arrangement that 40 minutes are permitted for us for this discussion. That's why I would like to give around 5 minutes to each one of panelists. Actually, we have 5 panelists in this auditorium, and also one panelist from New Zealand, Craig. Okay, nice to meet you. So, but it is available to be adjusted in accordance with the audience interesting. The time will be adjusted. And the further efficient manner to proceed this discussion, I would like to separate two parts. As you know, we have 2 sessions previously, and there are 3 panelists for 1 session, and the other 3 for the second session. But my personal perspective, there are much more interesting in section 2 rather than section 1. That's why I would like to give the chance to discuss on the topics which was dealt in section 2. So maybe the panelists you understand my intention, and then ready for the discussion. And also, I would like to ask the audience, if you have a intervention, please speak slowly and clearly for our panelists, including me, to understand correctly. And then it's going to be very appreciative. Thank you. And then, if you don't mind, I would like to start with on this panel discussion. First of all, as I mentioned, I would like to talk about the presentation 1 in session 2. The topic was development of a navigation facility for UAM and drone measurement system. So I would like to open the floor now, and then if you have any questions, raise your hand, and also introduce yourself very shortly, and then you can ask a question. Now, floor is open. Okay, thank you. Okay, would you like to introduce yourself and ask a question? Wait a minute. Why don't you give him a mic? Okay.
Thank you. Thank you. My name is Amgalan. I'm from Mongolia. And thank you for organizers, CRMS and RAPA. And thank you all presenters. I have 3 questions. First one is regarding the 600 megahertz. Is there any country using the APT?
I'm so sorry, Mr. Amgalan. As I mentioned, our topic is going to be UAM issue.
UAM issue.
Then I will give you a chance to ask a question for Mr. Craig. Okay, you are interested in 600 megahertz in New Zealand. Am I right?
Yes.
Okay, just a minute, please.
Okay.
Now, okay, go ahead. Your name and your affiliation, and from which country?
안녕하세요. My name is Zulhaidir Hamid. I'm from Ministry of ICT of Republic of Indonesia. Okay. I'd like to ask about the DIVA, UAM, DIVA system. Sometimes in my country we have like interference in the radar. Usually in the radar that for the using in the flight navigation. And it's usually coming from the 5 gigahertz Wi-Fi. This system have some experience in mitigating this kind of interference and radar. Please explain if the system already have some kind of experience in this kind of interference. Thank you.
Okay, thank you very much, delegate from Indonesia. Okay, Mr. Dr. Sang-Yun Lee, can you reply? Oh, no, I'm sorry. Who is? Mr. Hong, Deputy General Manager, KAC. Can you reply to his question?
답변하겠습니다.
Let me answer the question. So about your question, well, if I may understand right, so when the radar signal affected their navigation system, was it right?
According to my understanding, the 5G Wi-Fi system can give interference to the DIVA system. So if you have any kind of this kind of interferences situation in Korea, maybe he want you to explain your experience, how to solve that problem. That is my understanding. Is that right?
If you have some kind of this kind of experience, but if not, then it's okay. Because I think it's have some kind of potential. The system is have. Because in my opinion, your system have some potential to mitigate this kind of interference. Because the radar that's specially used by the flight, the one that used to identify the cloud, usually they have the really close frequency with the 5 gigahertz frequency. That's why they have sometimes the Wi-Fi 5 gigahertz Wi-Fi interference with this kind of radar, and usually we have to for mitigating this kind of harmful interference, we have to drive around the city just to identify which station that interference with the radar. But if we're using with drone with your system, I think it have some kind of potential to be implemented in this kind of scenario. Thank you.
Okay. Mr. Hong, Dr. Hong, are you ready for reply?
So the question is, as far as I understand, so the DIVA actually detects interference signal, so it has function to do so. So whether DIVA can be impacted by interference, and then whether DIVA can be used for detecting the interference. Well, first of all, DIVA can be affected during operation, whether it is 5G or radar. Because rather than frequency, because of the power, it can be impacted by radar because the power is very massive. So if we operate drone within that scope, then the drone's signal may be impacted, and it can even fall to the ground because DIVA is affected. But if you see the actual function of DIVA, well, its main function is to detect interference. So from 70 mega to 6 gigahertz, we can detect all of the spectrum. That means if we know the general spectrum that is being used, if the spectrum goes beyond this range because of interference, for example, then we can detect in real time. I was wondering if I have answered your question right?
예, 알겠습니다.
뭐 이제 부연 설명하자면.
So if I may give you additional explanation, we also have anti-drone system that has been established because we are airports operators. So like 10 giga or 24 giga is used especially for radar. So in the case in next year, anti-drone system DIVA will be used for the anti-drone system. So we may use up to 24 gigahertz. So we are currently under R&D process.
Thank you very much for answering. But basically, the Indonesia interested in the mitigation technology if there is included in DIVA system or not. If that is my understanding. Anyway, thank you so much for your answering for the questions. Any more questions? Okay, please go ahead.
Thank you so much. My name is Ahmed Al-Qaradawi from NTRA Egypt. And my question regarding the UHF band. The first question, what is the amount of spectrum available for wireless microphones?
Oh, excuse me, the colleague Egypt. Okay, like I said, okay, we are going to discuss on that matter later. Now we are focusing on the drone issue or UAM issue.
Yeah.
So sorry.
Thank you so much.
Maybe my English is not correct. That's why you couldn't understand.
No.
I'm so sorry for that. Just a minute. Wait a minute, okay?
Okay.
I'll give you a chance. Okay. Are there any other questions? Okay, go ahead.
Oh, thank you. And I have a question to meet.
Excuse me, sorry. Your
yes, sorry.
name and your.
Yes, my name is Chiêu Minh Tuấn. You can call Mr. Tuấn. Yeah, from Authority ARFM, Authority of Radio Spectrum Management of Vietnam. And I have a question to Mr. Jiao Lim from RAI of Korea. And could you explain why the 2.6 band in 6G will be arranged in low band, although today in 5G 2.6 and 2.3 now they are low band.
Excuse me, I'm so sorry to interrupt your question. You are questioning about IMT 2030.
Yes.
Oh, please.
It's been
please. I mentioned at the early stage that we are going to discuss on the drone issue, and then I will give another chance. We are going to discuss on IMT 2030 later. Okay, please sit down and then then later we'll discuss.
Yes,
on that. Okay, thank you very much.
Sorry
I'm
for
so
that.
sorry.
Thank you.
If you don't have any questions on drone and UAM, I would like to move to another topic.
Yes. I a small question about that topic from UAV. Excuse me, may I have a question on the UAV? Is that okay?
DIVA system or UAM system or drone?
Yes, I mean that I will question on the drone.
Yeah, okay, go ahead. About drone.
Yes. As you see, drone for using a lot of work to do, especially in radio frequency monitoring. And you can can you could share more experience or more talks about by using drone for monitoring and also the detecting the interference sources, because especially interference cost to empty that drone can using for ZSK. And also, do you have ever experience in using drones with spectrum analyzer can receive or detecting the illegal, especially in Earth station? Yeah, illegal Earth station is okay for detecting that. Thank you very much.
Okay, Dr. Hong, can you answer for his question?
예, 제가 이제 번역한 내용.
So, depending on the interpreted question, the question was, I don't know if I have understood right, but so what we developed from 2016 was to detect the quality of a spectrum in the air. So plus and interference that might exist, or the signals that come from outside our scope, our area, that might impact the air navigation. So we want to detect it in the air, and as you saw from the slides, because of the reflection wave, whether our signal are polluted or not. So we can detect these in the air with our drone system. So did I answer your question right?
On the topic of UAM and drone, maybe if you are interested more, and after a discussion, you can talk about that. Because please understand, because we have a time limit, that's why we have to ask a question shortly and then answer the question shortly as much as possible. The next item is local 5G status and use cases in Korea. On that topic, if there is anybody who has any questions, raise your hand and go ahead, please. Okay. So there are not. Okay, you can go ahead. Your name and your country.
Okay, my name is Amgalan. I'm from Mongolia. And regarding the 5G local 5G, the presentation is mentioned that 13 local 5G operators working in using the local 5G spectrum. How to get the spectrum license from ministry? Because the last 6G mentioned, and over 26 gigahertz is the assigned allocated to the 3 mobile operators. And then 5G local operators, there are 13 5G local operators. And I see that there's overlap in frequency with the local operators, local 5G operators, and mobile network operators. Could you please explain that? How did that local operators working? How they get the licensing?
Okay, thank you very much for your questioning. And Dr. Lee Sang-yoon, would you answer for that question?
네. 네, 말씀드리겠습니다.
Yes, I'd like to answer the question. So basically, for mobile telecommunication, this serves the entire nation. So exclusive frequencies are allocated, and so certain frequencies are only allowed for certain operators. However, EUM 5G local is for specific buildings or terrestrial areas, so they might be shared for certain areas. And when the frequencies are assigned by the government. They look at whether there's going to be any interference between the 5G EUM services or within the same area, and they would look at the output at the service area, and that would be set before the frequencies are assigned. And there would also be guidelines on sharing within a certain region the frequencies, and so they would follow those guidelines when assigning the frequencies. Also, for mobile telco, when the frequencies are being assigned, there's charged at a price, and the pricing is usually auctioned, based on auction. But for EUM 5G, operators who can use in that specific area, they would usually own land in that area, or they would have gained permission from the owner of the land. So there wouldn't be any competition in terms of the service demand. The service area, size, and the frequency bands, those would be the criteria by which the pricing would be determined.
There was a discussion regarding a little difference between mobile communications and local 5G, mobile communications and local 5G from the aspect of spectrum licensing. It is a good talk. Thank you very much. Okay, just a short question, please. Go ahead.
Thank you so much for giving me the chance to ask about the local 5G network here in Korea.
Your name and...
My name is Ahmed Al-Qaradawi. I am from NTRE Egypt. Okay. Yeah. The local 5G network used by mobile network operator, is it a standalone network or non-standalone network? And did they finish the coverage for the whole country, for the Korea? Thank you so much.
Thank you very much for your intervention. Okay. Dr. Lee, would you reply to the question?
네.
First of all, I would like to talk about how the network is set up. We are considering a 5G-based standalone network. For a non-standalone network, we will have to use LTE networks as well. But the mobile telco operators don't have LTE networks. They would have 4.8 network, and next about service coverage areas. I touched upon this briefly earlier, but EUM 5G spectrum license, to gain a license, the land or terrestrial area or building where the service will cover. So the person who applies for the spectrum, you have to either have to be the owner of that land or have to have permission from the owner of that land. And that's why it's going to be very difficult to gain a license for the entirety of the country. So there's no law that says that national coverage is not possible. However, in realistic terms, it's impossible to obtain license for the entire country.
Question and answer. Okay, I think we have to move to other topic. Okay, the next topic will be the ITU framework for IMT 2030 and IMT spectrum trends. So now floor is open, so you can ask a question about the IMT 2030 issues. Okay, Vietnam. Hey, please, you can sit, and then you can sit.
Thank you. But I can standing here. So my question is the same as I said before. Mr. Kim can explain why 6G will be arranged for 2.6 and 2.3 band would be low band, but today in 5G we are in they are all mid band. Yeah, because I think they change a lot. Thank you.
Okay, Dr. Lim, would you answer for that question?
네.
So first of all, thank you very much for your question. The IMT spectrum use global trend slide show the low band, the lower mid band, upper mid band, and high band. And before preparing for the 6G era, we need to prepare, but not only for the mid band, but also for the low band. So the refirming of the several frequency must be done for the low band as well. So remember the 4G LTE era. So we adopted 2G and converted to 3G and then changed to 4G, and then the leftover frequency from the 3G were converted and then were used for the 4G. So if we go to the era of a 6G, we can expand the frequency and we can use for different bands. But actually, this is not an official remark from our institution, but rather my personal view as an expert. So we have low band, and then LTE frequency can be expanded to be used for the 6G. So that's my view, but it's not actually a plan yet. Yeah, so it's my view, like expectation for 6G. What was important in my presentation was that additional frequencies can be necessary for the next generation. The coverage and capacity should be satisfied together. So that's a global trend, and that's why 3.5 gigahertz is necessary, but at the same time, expanded mid-band is necessary. So that's why we say lower mid-band and upper mid-band. So in the next WRC meeting, we will talk about this issue, whether we can make the upper mid-band. So we will see how discussion will go on in this upcoming WRC meeting. And then after 4 years, we will make a decision on the band. So we need to make it an agenda. Otherwise, we will need to wait for another 4 years. So 3G, 4G, 5G changed in 10-year cycle. So we think that it is now time to prepare for the future. Thank you.
He expresses the global trend and his view from his experiences regarding ITU 5G, 6 and IMT issue. Okay, I think it is understandable to Vietnam. Thank you very much. Okay, one more question, just a short question. Colleague from Egypt, please.
Thank you so much again for giving me the chance. My name is Ahmed Al-Karadawi. I am from NTRA Egypt. My question to Dr. Lee regarding the 6G network. As he mentioned that 6G network will be combined between terrestrial and non-terrestrial services. Do you think in that case there will be a more interference cases or issues between the terrestrial and the non-terrestrial networks such as satellite and terrestrial service? Thank you so much.
Thank you for your question. Dr. Lim?
네,
Thank you for your question, first of all. So, I went to Egypt for the last WRC and then I stayed there for 6 weeks. So as I meet you, I can recall the time. Well, NTM, like non-terrestrial network is an issue these days, but it uses satellite. But there are many different types of satellites. Geostation, for example, and non-geostation, and the low orbit network, and etc. So, about the frequencies that use NTN, well, you ask about the interference. So, the frequencies related to NTN are currently discussed. So, in the upcoming meeting, we will see how we can make it as an agenda item. In Asia Pacific region, the IMT frequency that use under 3 GHz is now under discussion. So because it will, rather than inserting new frequency, maybe we can use L band or global star or E-rhythm or other satellite network that is on the 2.1 gigahertz. So we are talking about connecting these. So we will talk about interference as an agenda item, of course, but maybe interferences that occur among neighboring countries, maybe the discussion result, I think. Just like T-Mobile and Starlink are doing within the terrestrial network. Some frequencies would be divided, but they should be discussed as agenda item, and we also need to conduct more research on this.
Detailed explanation about the trend of spectrum usage, even in WRC and IPT. Thank you very much. Okay, I'd like to close this topic and then move. I'd like to move to the feature of 600 megahertz in New Zealand. Mr. Craig Scott, are you ready for the discussion?
Yes, I am, and good afternoon, everybody.
Okay, thank you very much for joining us for the discussion. Okay, okay, raise your hand. Oh, you go ahead. No, just a minute over there. Mr.
Thank you. I am Yong-seok from National Radio Research Agency, and I'm glad to see you in the Global Spectrum Management Forum, and I hope to see you in Dubai and cooperate together at WRC 23. I have just a simple general question. In the perspective of the spectrum planning roadmap of New Zealand, how do you expect the frequency band for the future mobile service, not only 700 megahertz, which frequency band are being considered or will be considered to be used for IMT in New Zealand? Thank you very much.
Thank you for the question from Mr. So. Okay, Craig, can you answer to the question?
Yes, thank you very much for the question. So we have published a draft 5-year spectrum outlook, which identifies a few frequency bands to be considered for 5G and potentially future evolving technologies. 600 megahertz is one of those bands listed, but we also have 1.5 gigahertz, 26 gigahertz, and 40 gigahertz listed. That is, I guess, one more. So we also have listed is 3800 to 4200 for looking at that as well. And that is, I guess, on top of all of the frequency bands that we have available, which is quite a large number at this stage. Thank you.
Thank you, Mr. Craig. Mr. So is okay with you? Okay, thank you. Another colleague from Egypt.
Thank you so much. I'm Ahmed Al-Qaradawi from NTRE Egypt, and my question regarding the time and the cost used for migration from digital terrestrial television stations from 600 megahertz band to the 500 megahertz band. My question regarding the cost and the time used to migrate from 600 megahertz band to 500 megahertz band. Thank you so much.
Okay, Mr. Craig.
Thank you for the question. I guess the period that it took was quite a long time. So we started in 2007 on, I guess, standing up digital television networks in conjunction with the analog television networks that were continuing to work at that time. At that time, they occupied from 500 right through the whole 700 megahertz band. And progressively what we did was switch off analog, and then we had to restack the band. So we had digital television spread throughout 500, 600, and 700. And then when we restacked the band, we moved everything down to about between 502 to 622 megahertz. In terms of the exact costs, I probably might have to come back to you offline on that one. I can't really recall what the whole process cost.
Okay, thank you very much. We discussed the time and cost. Thank you. Any other question from the floor? Okay. If there is no more questions from the floor, and then we can, okay, go ahead. The Mongol, colleague Mongol. Okay. Is there a microphone?
Okay, correct. It's one of the current incumbent services, the broadcasting. Are there any country using this 600 megahertz for IMT? Are there any experience? There is any availability of the terminal and base stations?
Mr. Craig, did you catch his point? Okay.
Yes, I think I understand the question. So from my understanding, the United States and Canada are using the 2 by 35 megahertz band plan, which is N71. So I think there is a fairly good availability of equipment that supports those markets. Regarding the recent APT 600 megahertz band plan, or N105, that has only really just completed standardization, but that standardization does mean that RAN equipment will be developed, and over time that'll be incorporated into the chipsets for UEs, and that should gain some traction, particularly as other countries start to take that up. So I understand, I think it was India that might have been looking at a configuration in line with the APT band plan, but it is early days for that.
Okay, thank you very much. Like I said, we have a time limit, so I'm so sorry to give that. I'm so sorry that we cannot have more time to discuss on that. Anyway, you can contact with Mr. Craig by email, or maybe you can ask him a question if you need more. Thank you very much, Mr. Craig, for your remote participation. Appreciate it. Okay. Next, we are going to go to study group 1, which is dealing with the spectrum management in ITOR. If there is any questions or many special interventions on the activities in the study group 1 in ITOR. Okay. If we don't, okay, thank you very much. Okay, go ahead.
Good day, sir. My name is Yogo Prihandoko. I am from Ministry of ICT in Indonesia. My question for Mr. Hong An is how to overcome the problem of frequency that licensed but no longer be used. that to make the frequency more efficient. Thank you.
Okay, Mr. An, did you catch what is the question from the floor?
네, 일단 질문은 합니다.
Yes, thank you for that question.
How to overcome the problem of frequency that licensed but no longer be used to make the frequency more efficient and effective?
Understand exactly what you said. Speak slowly and
Okay,
clearly.
sorry.
Again, I'm so sorry.
Okay. How to overcome the problem of frequency that are licensed but no longer be used by the people or company to make the frequency more efficient and effective for allocation? Can I too fast?
No, I understand your question, but I'm thinking of how I can answer the question because
I think you're. I'm so sorry. Can you go ahead? Can you go ahead?
I cannot. Can we? I cannot figure out the exact method, but.
Okay, I think your question.
We can discuss later.
Okay, yeah. I think your question a little bit slight different. The main point of what he prepared in his presentation. I understand you are curious about how to redeploy, how to share, how to use the frequency that are no more use from the satellite, something like that. But I think that kind of issue will be discussed after discussion. Maybe another the expert on that interference or any spectrum planning area, and then you can discuss on that.
Oh, yeah. Thank you. No problem.
I'm so sorry to.
It's okay. Because the presentation is presented about the allocation of frequencies.
Allocation frequencies and unallocation frequencies. Okay, I see. Okay, I'm so sorry that. Thank you so much for your understanding. Okay, time is beyond now. Okay, there are. Oh, one more question. Okay, please go ahead. Okay, the microphone is ready for you.
Thank you very much. My name is Liz Kabarire. I'm from the Rwanda Space Agency. Mr. A, I don't know if I am pronouncing well your name, talked about the use of AI to automate the spectrum management. I would like to know the progress about this on this work and if there are any challenges that are being faced or that you oversee in this work and the expected timeline to complete this. Thank you.
Okay. Thank you very much, the delegate from Rwanda. Mr. Han, maybe you can ask, you can answer for the question. When do you expect the document, the report, that will be finalized? That is her question in study group 1.
Okay, thank you. Thank you, Professor. And the progress of the report is really premature stage because 2023 the Korea delegation proposed the contribution with the very first draft. So if you ask when it's going to be concluded, it would cost about more than 2 or 3 years. So if you're interested in the topics, maybe you can join the work of the report process, maybe in next year, 2024, which is the next XG1 is gonna be held.
Okay.
Thank you.
So you understand exactly. Okay, thank you very much. Okay, time is run out. So just we're going to go to the last topic, spectrum monitoring process in Korea. I would like to have just one one question from the floor, okay? Because time is running out already. Okay, please go ahead.
I'm so sorry. Is it okay if I have 2 questions for this topic?
Yes.
Okay. Okay. My name is Zulhaidir Hamid. I am from Indonesia. I really interested with this topic, and I'd like to know, first of all, how do you manage to integrate all of the system into one system that you can view from your from the sole CRMS office? It's like, because I know probably there is a lot of brand for this kind of operation, maybe from Rohde, from TCI, and also maybe from your local brand in manufactured in Korea. And how do you manage to integrate all of this brand into one system that you can manage from one desktop application? Okay. And the second one is about sorry. About the data that you collect from all of the station, because as we know, the speaker mentioned about the CRMS monitoring all of the spectrum. They do it in 24/7, like every time they do the monitoring, and then that means you need to gather a lot of data from the spectrum. Please give us like some what kind of data that you collect from this system, and how do you manage to collect the system? Because as we know, the data from the frequency is really a lot. If we have to collect that, like every time we do measurement, we have to collect. That's all for me. Thank you.
Okay, thank you very much. Okay, Deputy Director Lee. Okay, can you answer for his 2 questions?
예, 질문 감사합니다.
Thank you very much for those questions. Regarding your first question, the Republic of Korea, CRMS, oversees the following systems. Actually, all of the data is monitored through fixed and mobile monitoring systems across 13 regional centers. All of the radio spectrum data is collected real time and accumulated, aggregated real time. So that regional data is brought into the broadcast communication system in the center, and that is processed and analyzed. So in terms of systems, they are already in place, and we are operating them and managing them. And of course, many vendors have participated in delivering those systems, and they are also engaged in operating and managing those systems. And we are going to continue to upgrade those systems for quality management of that data.
24시간
Regarding your second question about 24/7 monitoring, so you mentioned the massive amounts of data, and yes, that is true. The raw data that is collected from each regional area is, yes, massive. And we have to extract data that is significant to us. For example, about interference or any discordance or disturbances. We would extract data from licensed bands to analyze them and respond accordingly. As you mentioned, to manage all of the raw data that is generated across all of the bands and ranges, that would require really big storage equipment, and we have limitations in that regard. So that's why during my presentation, I touched briefly upon using new technology to do radio monitoring. And the paradigm for radio monitoring will shift to more use of artificial intelligence or big data. So digital radio monitoring platforms will be needed. So all of those massive points of data will have to be collected and stored and processed and analyzed on an automatic basis for them to be used by the public or the corporates. And I believe that a service that responds to those needs will probably emerge. In that regard, we're currently undergoing ISP studies. And we, of course, have to obtain budget to that end. I hope that answered your question.
From Indonesia, strongly interested in what kind of data are supposed to be collected from the system, monitoring system. In my thought, maybe carrier frequency, occupied bandwidth, and the modulation scheme, and the power level, such as maybe those kind of all parameters will be detected and analyzed, I think. Anyway, it is time is over. That's why I have to finish this discussion. And before the conclude the discussion, I would like to give a high appreciation to the participation in person and even the remote. Craig. Thank you very much and have a nice evening and see you tomorrow session. Thank you very much for your participation.
Well, thank you. Thank all the panelists for sharing your insight and knowledge. So your discussion allow us to take a close look into the theme. And my special thanks also go to the moderator for leading this fruitful discussion. So would you please give another applause to them? Thank you. Well, this is the end of the panel discussion. But before we conclude this session, I have an announcement to share with you. We are conducting a survey to make this forum and programs better. So please share your opinions through the survey. So for those present at the venue, we've already distributed survey forms along with your program book. So please complete the survey and submit it to the registration desk. And for online participants, we have also sent you a survey link via your email. So please request to complete the survey and submit it. Well, that brings us to the end of the forum, but this is not a real end because we'll continue tomorrow. So we'll commence tomorrow at 1:30 Korean time. We look forward to your continued interest and participation tomorrow as well. And guests, they were scheduled to attend the meeting, so follow the instruction of our staff, and the bus will be waiting for you at the main entrance. Wishing you a pleasant evening. I hope to see you tomorrow. Thank you.